Does that make sense?
Not for
What?
the, not for the pH.
Yeah, okay, wait a minute. What about the pH?
Maybe. Why is it hydrogen, oxygen, carbon, and
Because, first of all, the question asks about what elements. So I'm only interested in the, of that field, I'm looking at the elemental form, and that's usually on the right-hand side, and the reduced form on, the exception being oxygen's on the left-hand side. The elemental form of oxygen is on the left-hand side of that reduction reaction. So if the reduction potential is greater at 0 pH, because that's all we're asking, if the reduction potential is greater than minus 0.6 volts, they're stable with respect to oxidation by the solvent. And the only other thing we have to be concerned with is stable towards reduction by the solvent, and that means they have to be below, they're all below 1.82 volts. So they're all stable with respect to being reduced by the solvent, and all the ones with a reduction potential less than or greater than minus 0.6 volts are stable with respect to being oxidized by the solvent. And so the answer, so I got, now that I've written all this, I will write the answer down. The answer for part A is hydrogen, oxygen, what are the other ones? Oh, copper,
Nickel, bromine, manganese.
nickel, bromine. Is there any other?
Manganese.
Manganese. Well, that's not an element.
Oh,
That's an ion.
time.
Okay? So that answers A. That's not that tough question. Now, which ions are stable in water at pH 0? So we're just extending that argument to apply to ionic forms, and the only one that's ionic, and well, there are several ionic forms. They're on the left-hand side. Zinc is in the 2+ form. What's going to happen is it's not going to be oxidized. Is it going to be reduced? Well, no. In order for zinc to be reduced by water, it would have to have a reduction potential that's greater than 1.89 or 9 or 82 volts. Okay. So, in other words, all of those ionic forms are going to fall in that category. Though with the ionic form that's most of interest is the one manganese 3+ to manganese 2+. We have that reduction potential 1.51 volts, which is above that of oxygen, but not far enough above it's not 0.6 volts above that of oxygen, 1.23 volts. It's still within the barrier. It's not going to have enough to overcome the kinetic barrier, the activation energy, which is manifest in the overpotential. So that means that the manganese 3+, the manganese 2+ ion is going to be stable in water. The bromide ion is going to be stable in water. The nickel 2+ is going to be stable in water. The copper 2+ is going to be stable in water. And the zinc 2+ is stable in water. The hydrogen ion is stable in water. So, because what I asked was which ion, so let's start at the top for part B.
So you just use the original B knots? Like you don't
Yeah.
have to change them?
Yeah, because we're under standard conditions. This is pH 0. You know, the reason I wanted to generate the graph that we generated earlier so you can understand more completely what happens, because we don't often work at pH 0. Oftentimes, most of the water we deal with is neutral or in that a narrow range around 7. And so, in order to understand that and understand the water's chemistry, we have to have that graph. But This question is restricted to at pH 0. Okay? Okay, so let me answer this. Which ions are stable in water at pH? I guess I can erase this. Yeah. That was A. Now let's get B down there.
Wait, why is zinc ion okay?
The ion, zinc metal, is going to be oxidized by water, but the zinc ion is not going to be oxidized by water. We're more concerned about, in order to be oxidized by water, the ion would have to have a,
Because it's below
Yeah.
the negative.
yeah, it would have to have, it would have to have a reduction potential. It would have to be the reduced form. It would have to be the reduced form in a reduction couple, the redox couple, and the reduction potential would have to be less than minus 0.6 volts.
Yeah.
And that's not the case. So it's not going to be oxidized. Whether it's going to be reduced is going to, it's going to have a reduction potential. To be reduced by water, has to have a reduction potential greater than 1.8283 volts. 1.83 volts. Yeah, that's it. 0.6 volts plus 1.23. Okay. So, and that's not, none of the candidates in our question fall into that category. So for part B, the ions are going to be hydrogen ions, zinc ions, basically all of them. You just got to figure out which ones are ions. Nickel, bromide, and manganese 3 plus, and manganese 2 plus.